Chapter 26, Graphing Linear Inequalities in Two Variables. We're interested in finding the region of all the points on the rectangular coordinate system whose coordinates satisfy a given inequality. We shade such a region. Consider all the points in the xy plane. A line, or really any closed non-overlapping curve, subdivides the plane into two regions. Let's refer to this line as a boundary. Like the geographic boundary between the United States and Canada, or the United States and Mexico. All the points on the plane are represented by an ordered pair of coordinates, x, y. Some of these points are above the boundary, some lie on the boundary, and some are located below the boundary. The boundary is represented by a linear equation, at least the way what we are doing with right now. The equation is identical to the inequality, except that the inequality sign is replaced by an equal sign. Draw the boundary on the Cartesian coordinate system by finding 2 points on the boundary line, preferably the intercepts. The intercepts are usually the easiest to work with. Then, after you've drawn the boundary, pick a test point which does not lie on the boundary. The origin, in which x is 0 and y is 0, is the simplest test point, and if that origin happens to be on the boundary, since you cannot make both x and y 0, make one of them 0. Substitute the coordinates of the test point into the inequality. If the inequality is true, the test point identifies the region to shade. In other words, the solution set. And all the points on the same side of the boundary as the test point have coordinates that satisfy the inequality. If the test point does not satisfy the inequality, then shade the region on the other side of the boundary.